Hi guys, welcome to my workshop. This is part 2 of making the power supply for my workbench. So I have a piece of aluminum sheet on the bench and I put some lines on there already, and I started already with cutting the corners out. This will be bent over later on. And that side and that side and that side will be bent, and then we bend all together and we get a frame where we can put the transformer on. We fix them together with some rivets, so it will be a very sturdy frame to put everything on. So I will carry on now with cutting and see how it goes. Well, it's not very easy, mind you, with this cutting tool. It is very handy, but again, not that handy, but doesn't matter. It is a handy cutting tool. Sometimes it takes a little while. Sometimes it works, sometimes it doesn't. There's only 1 mil. We'll have to put some oil on there. That makes it easier. There we go. Keep on more. That one's done. So we'll do the other side. And the same way. Probably an easier way to do this, but I have this tool and I always work with it. I made some things in my time, so the other thing with this tool, very handy if you have a display. I don't know if you can see on the camera. No, we can't see it. What I can do is zoom out a little bit. Zoom out a little bit. There you go. If you can see here, the display. Yeah, this tool is very handy to cut out something like that, and then with a file or something like that to get that straight. But I use that often for that. So it's a very handy tool for that matter. I will zoom in again. There we go. Okay, let's carry on. Get the bucket underneath. I'm going to sweep the floor in a minute. That's not what I want. Allez. It doesn't have to be precise in the middle, it can be a bit off, it really doesn't matter. Just that we can bend this over properly and fix it. And that's what we want to do with it, so you have to be accurate like that. It takes off 1 mil every time you cut it, so there you go. Well, I'll do it off camera. I think otherwise this video will be endless. So, and then I will show you how we bend this. Alright? Back in a minute. Welcome back, guys. As you can see, I cut this out, and now we we're going to try to bend this, and it can be easily done. And to get nice sharp edges, so we'll carve them a little bit, yeah, and then you will see it will bend quite easy. First of all, I going to carve the metal a bit, so I'll put it on like this. Make sure that it's right. Put a clamp on that side for starters. Takes a bit of time, but there again, yes, if you take your time, it will be okay, and it will work fairly easy. Put another on the other side. Now, get it straight with the wood, and we get happy with that. To get this straight with the front edge, and we can put it down here on the line. There we go. Now, that's it. A sharp knife. Twice is enough. It's more than enough. So I have to do the other 4 edges. Loosen this up again. And then we do the same thing on this side. The clamp on again. Tighten it down. Knife again. That's it. There you go. As you can see, you have to take your time. Never rush this. Not necessary. Unless somebody is watching you. There we go. I want to go. And now we start bending this. I use a normal workmate for that. I'm sure some of you will have a workmate in the shop. So it gives you some ideas how you can use your workmate, or actually how to destroy your workmate. I'll show you in a minute, and you know what I mean. First things first. So tighten it down. There we go again. That would be it. What you do, take this off. Take this away. And then we put this, have a look, the right way here. Have this edge here. Now we're going to put it on that edge. That's right. And tighten it down. Make sure it is on the line. Allez, come on. So, make sure it is on the line. If not, you're in trouble. Now, tighten that up. Now we're going to bend it over. You see, it's not very easy, but it works. Everything takes time. There you go. That's the first one. There you go. Put the other one in. The same way. Okay. It's the same way. That's not the workmate, that's the metal. What you hear cracking. You don't have to attempt it with thicker aluminum. You won't be strong enough to bend it over. So it only works with 1 mil. So there you go. First part is done. Now what we're going to do next is to bend this part that way and making sure this goes on the inside. Alright, so we only use the other side for that, so it has to fit on here to bend it. I'm going to do it a bit different. I'm going to use this for that, but it will do the same thing, there won't be any problem. See, put it on the edge on both sides in the opening. Afterward, you can get it apart so it fits. There we go. You've just watched the line here. That's the edges on that line. When you got that, it's okay. Then we put this on. We put our clamp on, hopefully. Now we want I need something to put underneath, otherwise we're going to get this shot. Okay. Well, there you go, that's the first one. Well, don't worry. See what we can come up with. Let's put the clamp the other way around, that's all. Someday he's going to catch. There he goes. Just that. There we go. Put it underneath. And tighten it up. There we go. Just make sure that line is on the correct position, otherwise you get a false bend and you don't want that. Put that further in a bit, and that side also, we get past it. Okay, let's attempt to bend it. Do the same cracking again as the metal. Yeah, that's okay. As you can see, it's hard work to get this. My camera's in the way. I know. It is doable, but okay, I better throw it in a minute. After the first one. Well, have to fix them differently. There we go. You see, if you make a mistake, you can always correct it. You put the clamps the wrong way in, but it doesn't matter. You correct it and do it again. Just push on it, and this goes fairly easy now. There you go. Next time around we know how to do it. Next one. I intend to show you completely how it is done and how it is not done. So at the same time, you see, make me the mistakes, and you can learn from that. So there you go. You put them together with some rivets, and then you have a sturdy frame. Yeah. Just put it that way. And just be patient, and it will be okay. As you see, oi, everything the other side, I think. So, oh, yeah, that happens too. I'll never do it this way, huh? It doesn't matter, really. We have to put the clamp on the other side again. So, see, I bent them over a bit inwards, so we get past this. And put that on there again, so like that. Just making sure that the line on the end of the wood there we go. Put in there. Oh. Okay. Now. Oh, I like to fiddle. As you can see, I like to fiddle. And that's why it's a hobby, eh? If you have a hobby and you like to fiddle. I like to fiddle a lot. Let's go on this side again. And then hope for the best. There we go. Tighten it up, yeah. There we go again. And my clamps are in the way again. I'll think about this for a minute. Get rid of that one in the first place. Put them on the other side. There you go. Oh, come on. Let's have a look if we can clamp this. That's the same way, isn't it? I just have to wing it, I suppose. We're going to get through this. I'll take this off, we will, hopefully. There we go. There we go. Never give up. That's my team always, never give up. There we go. There you go. What a fiddle, eh? There you go, guys. And this is drilled and riveted. That is very sturdy. There you go. So I will have a pause for a minute and then come back to you, okay? Hi guys, I'm back again. I took a little break, so have some lemonade, have some peace and go out. We do it on our own time, so nobody is chasing us or anything else. So I did the riveting already, so I put them in on both sides. You can see it's quite a sturdy frame. So I had a look at the schematic. I'll come back later on that one. I will show you the schematic, but first of all I'm trying to decide where everything will go. So let's put this transformer here on the front, like that. So I have that EL34. Yeah, this one. That's quite a big valve. So actually a brand new one. Have a look where there we go. Here's a socket of the EL34, and I could put it down there. Yeah. And the two 12 AX7s there. Yeah. That would be a possibility. Let's take a look how this fits. We don't know that yet, so we'll try to decide where everything will go. So this will go on the front with the Anders terminals from 6.3 and 12.6. Now those windings. I left those wires long, so I could eventually connect them up there. On top of that, I want to put in at least 4 meters. Well, you see straight away this is not going to work. So straight away I get into trouble with spacing on the front. So it has to go to at least 2 pots and several terminals, so that won't work. And this little space here is too small, so that won't work. You have to put everything on front. There will be another front bit come in front of here, and there have to go where the meters go in. So as you can see, this positioning won't work for this thing. So I think perhaps it is, I could do it this way, with the transformer away from the front. Put them on the back here, like that. And we could put the EL34 here, anyway, and then get those 12AX7s down here. So that would be a possibility, if we have enough space. Well, we have to have enough clearance for the meters, so whatever they're going to be. So I take these meters away, I'll turn around a bit so we can see. Yeah, you can see we have not, if we put it that way, we don't have enough clearance, I think. It will be very, very tight, yeah. Now, we could move it back a little bit, so that should perhaps work. Then we have enough space on the side to put some terminals, if it comes to it. Then we get those two terminals can go on the bottom here. That should be able to. And then put the other meter down here. Then you have already enough spacing to put terminals and pots in one certain place. So on top of that, we have to know how big that EL34 is. The size of this EL34. It comes about 4 inches, say 10 centimeters. So if you put that on top of there, I'll put that away before it breaks. Put it on top of here, 10 centimeters, and take another inch or more, say 3 centimeters more to have enough clearance. Yeah, and then we can put 2 meters on top of one another. So we can put it on the other side as well. And we let ourselves enough space to put terminals and pots. So the other things will be voltage regulators. There's one voltage regulator that goes from 0 to 30 volts. Well, that won't take much space, so we can put that on the bottom if it comes to it. But still, there's enough space on the back here, so there's a huge transformer. So perhaps we can come up with something else, I don't know yet. So not necessary to put that down here. If you have so much space, well, you can clamp it all together, so we just as well put it down there. Yeah, put the valves down there and then get it. Well, we have the space, I think we should use them. Whoop, there you go. So I think that would be not too bad. Let's try this positioning, and I think I didn't decide yet if I put it in a wooden box or something like that. So I just have a panel on the front, but if every meter goes on there, separate. I just have to make up my mind about that, but the next thing I'm going to do is get the schematic on paper, a bit bigger. It's a very small schematic I have, that's hardly readable. So I'm first going to look into that, so I get that properly done, so I can put it on the whiteboard and put it on the bench, and I can show you the schematic what we're going to do. So but some mechanical things have to be done still, so I have to decide if I go and make a panel and put it up front here. So I have to decide that yet, but I'll come back when I have the schematic done, and then we see how it goes. Okay. Hi guys, as promised, I'm back with the schematic. See, it is a very simple schematic actually. It concerns 3 valves, actually 2 double valves and a single one. So it's the EL34 and it is here the 12AX7 and here the 12AX7. As you can see, perhaps not obvious for most of you, this is the where the voltage comes in, 280 volts. Yeah. We have here the regulation of the voltage with the first valve. Yeah. There's also a cathode follower, as you can see, and there's a double function here as a stabilizer. Yeah. And we have here where the voltage goes through this up to this grid here. It's actually very simple. If you want to have more explanation, I will provide it on a later date. Well, as you can see, that's the regulation of the voltage, 280 volts. The only thing that we have to bear in mind, that some resistors, this one for instance, or those two, can be swapped. Actually it should be then 25k and this should be 10k. That gives you the opportunity to lower the voltage a bit further than this. Like I can't really tell how much voltage is going to be, there's actually guessing, but we could swap them around so the voltage on this side will be lower, just in the outside here on the exit it will also be lower. We could have some advantages, but I have to see how that works out. I will first of all install it as the schematic provides, but it could change. This 47k could change as well. Perhaps I'll make the altogether make 100k, so you can divide it in 10 or 280 volts filtered. Well, 280 volts over 100k, every 10k will be then 28 volts in theory, that is. Yeah, so we could go down to 28 volts. If that is the case, we have to see. All right, I actually have to see how low it's going to go on this side. So I will do some investigation to explain the schematic a bit more detail later on, as I promised. So, but bear in mind, we could have some changes somewhere, yeah, in the resistance. So I expect that this one could be changed. I'm not sure of that, but even that one could change to 74k. I don't know. We have to see how it works out. But there again, and so far that is what the first schematic concerns. The other schematic actually for the low voltage is quite, well, easy, simple, and is readily to find on the internet. So it will be a 40 volt regulation up to 1 amp. So with the LM, what is this? LM370 voltage regulator. It could be additional to that, and as you might be aware, there are more voltages on there, but I have to tell you something about this, about those voltages concerning those valves here, all the filaments here. As you may be aware that every valve has a voltage concerning cathode filaments as a maximum voltage is there. So that, for instance, could be 150 volts here, yeah, and it could be perhaps also 100 volt or 150 volts there on that valve. If for some reason, I would say a stupid reason, you would put the 6.3 volts from that one, or the 6.3 volts from that one on, say, this section on the nil on chassis. So this won't be connected to chassis because it will be floating. So if you would do that, if you put that, you actually put 280 volts on this cathode and the filaments. But the result would be you have a very nice shiny spark in that valve, and that valve would be gone forever, not usable anymore. So bear in mind, if you build this and you following along, bear in mind that you have to isolate the filaments from the null, from the chassis. But it's not a chassis either. So, because of reasons, if you're going to try some apparatus, you have to be free from chassis. So, now that's about it, I suppose. You can make a nice combination. I will keep everything afloat above chassis. I won't connect it up, so everything will be separate on its own. So you can swap polarity as you need. So, but that is the main important reason why you going to connect them up on the transformer. Twist the wires, you have to do that, and then connect them up with the filaments with each valve. So there will be no difference between the cathode and filaments at all, so the valve will survive that. Well, that's about it what I have to say about this. I'll get this board off the table and then we talk a bit further. There we go. As you can see, I put all the meters up here. I put some parts here. I changed that socket. I didn't like that socket very much, so I put that socket in. So I think I put the camera on a bit of wide angle, so it will be much easier to see. I'm afraid it won't work otherwise, so I zoom out a bit. So that I think is a lot better. Well, as you can see, I put some stuff on there, some electrolytics. Well, I have to still buy my terminals, but I have those in stock. Those the sockets for the 12AX7. There you go. Yeah, both of them. Yeah. So the EL34. Actually, I had to go back in my stock and find another valve, because I noticed because of material problems this valve would be too long and this one would just fit into it. But I thought I solved the problem, because the material I used to make the cabinet, put it all in, is about 15 centimeters. Have a look at that. Yeah, well, it's the back part actually, the front part. I'm working on still. So this is the back part. You have a look at the size of the transformer. I measured that, and this part what I put on there, this strip, I connected all nicely up, will be just above that. So you can't put any covering on it if you would short out the whole transformer. So this has to go, really. And yeah, that's about it. So you see when you build things you can make mistakes. Did you notice that when you are working on it and you take the material and it's only 50 centimeters wide and you want to make the measurements, and oh, well, that falls short of that. So you have to make amends to that. So I have to remove this, and I will solder all up those wires here, solder them, so you can, other wires can solder to it. So I've done that before, there's no problem. So that's that so far. Now I did some preliminary drillings already about the transformers going to be. I put some holes in there. This is what the valve sockets are going to go. So what I'm going to do now, I will drill those holes, what I need, and take it from there. So I don't know if you are interested in drilling those holes. If you're not, I'll you pass over this part. Okay, I get my drill and get going. I put my drill. Oh, there we go. And yeah, that's the right one. I will drill out those holes first. Get this wheels a bit out of the way. Put them down there somewhere. Nothing happens to them. There you go. Now, first of all, we'll drill out those holes. The battery is empty. Oh, I'll take them off. I'll put another one on. There we go. That's full. A lot more power now. You see, it goes quite easy. Get rid of the rubbish. So, I think I will drill those holes off camera because there's going to be a lot of noise and just as well, I suppose. So I'll see you back in a sec. Well, there you go, guys. I've done the drilling. So every socket fits in quite easily. So this one goes on the bottom, put them up there. You see, this will be fine and that's what we want. So I want to look into how we proceed, how we're going to do it without making mistakes. I can see my foot on that side as well, you will be so high then. This is a tool I done this with, a very handy tool actually. You can make the holes as big as you like. So there you go. I'll put it back in the pot. So that's it. Well guys, that will be for part 2. I think that will be best, and then I will finish the front, get the meters in, put the terminals in, the switch, on and off switch for the transformer, put the back part in the socket with the fuse, whatever it needs to be done, make the part that covers it. I will do off camera, and when I get back to you in part 3 you can see more or less how this thing's going to look. Anyway, I have some pots here, and as you can see we have a very long axle on that. So what I will do is put a support in here to put the pot, say like that. A support in here, put the pot in that, so it will be much easier to connect them up. A little bit on 2 sides, so we have to decide how we're going to proceed. Anyway, you can see there's plenty of room to put the other parts in, so there won't be any any problems or something like that. So it will be fairly easy, and we'll come back to you when we get that far. And in part 3 we will construct complete apparatus, the regulated power supply, and we'll do some tests on it and see how it goes. For that I'll see you next time in part 3. Bye for now.